All right, this is part two of what I was talking about with the respiratory system. I'm not really sure how the video got cut, but I ended the previous video explaining that partial pressure of oxygen is higher in the blood and the capillaries, or the systemic capillaries, than it is in the tissues. So that means that because of the pressure gradient, remember, pressure gradient always wins. Pressure gradient, the pressure of oxygen, of partial pressure of oxygen is higher in the systemic capillaries than it is in the tissues. So that's going to make oxygen diffuse out of the pulmonary capillaries and into the surrounding tissues. The cells are then going to use that oxygen for what they do with oxygen, which is aerobic metabolism or aerobic respiration. That's when cells use oxygen and they produce the vast majority of their ATP within the mitochondria, using that oxygen and whatever substrate that they use, whether it be pyruvate or some other fatty acids. So they produce copious amounts of ATP. In the process of producing that ATP, they produce byproducts of water and carbon dioxide. So now this carbon dioxide, which is a gas, has now been secreted out of the cells, and that carbon dioxide now diffuses into the systemic blood that's passing by. The reason why it diffuses into the blood is because of partial pressure and pressure gradients. The cells just used up a bunch of oxygen, so they've created a whole lot of carbon dioxide. That means that there's a higher partial pressure of carbon dioxide in the tissues than there is in the systemic capillaries. So because of the pressure gradient moving from high to low, that higher partial pressure of carbon dioxide in the tissues moves carbon dioxide into the surrounding into the surrounding systemic capillaries, where there's a lower partial pressure of carbon dioxide. That carbon dioxide, when it gets into the blood, it's actually quite soluble in water, and most of your blood is blood plasma, which is 92% water. So the carbon dioxide, it can either dissolve in the blood plasma, or it can bind to the hemoglobin inside the red blood cells, or 70% of it will wind up coming into contact with enzymes within the red blood cell and converted into bicarbonate ions, and then it travels in the blood plasma in the form of bicarbonate ions. And all of this carbon dioxide travels with the blood all the way back to the lungs, where once it arrives at the lungs, specific the alveoli in the lungs, there's a higher partial pressure of carbon dioxide in the blood that just arrives at the lungs than there is a partial pressure of carbon dioxide in the alveoli. So thanks to the pressure gradient that's formed because of that, the carbon dioxide in the blood diffuses into the alveoli, and then you exhale. Now, when you exhale, we see Boyle's law back in action again, where if I want to push air out of my thoracic cavity, what I'm going to need to do is I'm going to need to make the volume of my thoracic cavity less, so that the pressure of air within my thoracic cavity is higher. Because remember, there's an inverse relationship between pressure and volume when it comes to Boyle's law. One goes up, the other goes down. So if I make the volume of my thoracic cavity increase, then I make the pressure decrease. But if I make the volume of my thoracic cavity increase, then I make or if I make the volume of my thoracic cavity decrease, then I make the pressure increase. So let me say all that all over again, because I may have lost somebody there. So according to Boyle's law, pressure and volume have an inverse relationship. If I make volume go up, I make pressure go down. If I make volume go down, I make pressure go up. And that's what I'm going to do with my thoracic cavity. I'm going to make the volume go down so that the pressure goes up. I'm not going to say it. I had another hip-hop pun. But anyway, you get it. Fat Joe all the way up. So I make the volume drop. I make the pressure go up. Now the pressure within the thoracic cavity is slightly higher than the atmospheric pressure around me, and that creates another pressure gradient. And then now that I've made that instantaneous pressure gradient, the air inside of me is going to want to leave and join the air around me, and I exhale. And that's that full cycle. That's that full cycle of the image that I was showing you earlier. I got a bunch of stuff on top of the picture now, but that image I was showing you earlier of the 8 different blocks. This image is at the end of your text, your chapter 23. It's at the end of that chapter. All of these things, this image, it's showcasing all of the different stages of breathing, all the way from inhalation to exhalation. And you want to be familiar with that. You want to be able to walk someone else through that. It's not like there's going to be a gazillion questions about that. It's only going to be 25 questions on the test from the respiratory system. But a good healthy chunk of those are going to actually come from understanding things like partial pressure, Henry's law, Boyle's law, Dalton's law, understanding things like the movement of gases, hemoglobin, its role with gas transport, that kind of thing. It's important to know that stuff for the test. Now, just to conserve time, I want to go ahead and move into talking about some stuff with digestion. And here's some things that you need to keep focused on when talking about the digestive system. There's 5 things that you really need to know for before you get on this test. Number 1, you want to know the cells, the important cells of the digestive system. The chapter and any of the notes and any other videos that I post, they're going to make it a point to talk about key cells. Like, you should know what the parietal cells and the chief cells are doing in the stomach. You should know that the parietal cells are the ones making hydrochloric acid, and you should know that chief cells are the ones who are making pepsinogen, which converts into pepsin. You want to know those things. So cells that stick out like that, know them. The second thing you need to know are secretions. So you need to know where bile comes from. The liver makes bile. The gallbladder stores bile. And bile emulsifies fats. You want to know other secretions like enzymes. So you want to know that pancreatic amylase is for breaking down sugar by the pancreas. Salivary amylase is an enzyme that's there for breaking down sugar in the mouth. Carboxypeptidase is an enzyme from the pancreas that helps to break peptide bonds so you can break down protein. These are secretions that you need to know. Organ functions. You want to know the basic functions of each of the organs of the digestive system. So whatever you do, don't get on the test and say that the large intestines is responsible for digesting protein, because that is a fib. The large intestine isn't really digesting anything. It's the bacteria in your large intestine that get a hold of certain nutrients and break them down further and allow you to absorb vitamins from those. You want to understand food movement. So you want to understand what's a short contraction versus what's a short movement through the digestive tract versus a long movement through the digestive tract. You want to be familiar with that. You want to know what peristalsis is. And then also, lastly, you want to understand phases. So like deglutition, the process of swallowing, that happens in phases. Gastric phases, you want to understand that too, the phases of stomach digestion, because the phases of stomach digestion are a trip, because they start with seeing or smelling or thinking about food. There's no food even in the doggone tract, but it gets you going. So I'll try to make another video here in just a moment to kind of go a little more in depth in how to study for the digestive system, and hopefully we'll get that loaded and see you soon.